This is an instructional video on 4 of the properties of exponents. So with these fill-in-the-blank notes, I'm going to give you the shortcuts to each of these 4 properties, and then we'll go into detail about how these shortcuts work when we do the actual practice problems. So for the first blank, it says we know that 5 to the third power means 5 times 5 times 5. The 5 is known as the base and the 3 is the exponent. That's what our second blank is going to be. 5 is called the base and 3 is called the exponent. Any number raised to the power of 1 is equal to that number. For example, 8 to the first power is going to be 8, and 50 to the first power is going to be 50. It just stays the same. Any number raised to the power of 0 is going to be equal to 1, and it's always going to be a positive 1. So for example, 12 to the 0 power is 1, and 100 to the 0 power is 1. For our second property on multiplying like bases, it says when like bases are being multiplied, their exponents can be added. And so for example, they give us this problem, x with an exponent of a, and then again x with an exponent of b, and we would do a plus b to get our final exponent. For dividing like bases, when like bases are being divided, the exponents are going to be subtracted. So again, they give us an example. We have an a exponent and we have a b exponent, and we would subtract those numbers to get our final exponent power. And the last one, it's power to a power. You'll also hear this called raising to a power. They both mean the same thing, it's just 2 different ways of saying it. When an exponent is raised to another exponent, the exponents can be multiplied. And again, with our example, we have an a on the inside of the parentheses and a b on the outside, and so we would multiply a times b. We would multiply whatever those numbers are to get our final exponent. So here's our first problem, 8 to the 7th times 8 to the 3rd. And since we're multiplying, our shortcut is that we're going to add the exponents. If we simply just add the exponents, 7 plus 3, we would get 10. And so our answer is going to be 8. The base number stays the same. Our exponent changes to a 10. Now I'm going to show you why that works. I'm going to start with 8 to the 7th power. I'm going to write that out as 8 7 times. I'm going to do the same thing with 8 to the 3rd power. If I take all 7 on the left and the 3 on the right, I have a total of 10 eighths, 8 to the 10th power. For this problem, we have q to the 9th power divided by q to the 6th power. Because we are dividing means we are going to subtract the exponents. And so we would have 9 minus 6, which is going to give us 3. And so our answer is going to be q to the 3rd power. But let's talk about why that works. If I start with q to the 9th, I would have 9 q's. I'd break it down. And then on the bottom, I have 6 q's. And what we can do is we can pair them up and cancel them out. We match one on top with one on the bottom, and we are left with 3 q's left over, q to the 3rd power. For this problem, we have 4 to the 8th raised to the 2nd power. Because we are raising to a power, that means we are going to multiply the exponents. An easy way to remember that is when the exponents are side by side, we end up multiplying them. And so that would be 8 times 2, which is going to be 16, which means our final answer is going to be 4 to the 16th power. Now, to break it down and show you why that works, I'm going to split it up. I'm going to start with my exponent 2, the exponent that is on the outside. I take my 4 to the 8th, and it means that I have 2 of them. We break them down. I have 2 as my outside exponent, so I do 2 of the parentheses. Then we can break it down again in 4 to the 8th 8 times. For a total of 16 fours, 4 to the 16th power. So for this problem, again, we have m to the 3rd times m to the 0. Again, we're multiplying, and when we multiply, we're going to add the exponents. My exponents are 3 and 0. And when I add them, I get 3. And so my answer is going to be m to the 3rd power. Let's talk about why that works. If I break down m to the 3rd, that would be m 3 times. And anything to the 0 power is going to be 1. So that would be times 1. So m to the 3rd power would be m 3 times. And then we know anything times 1 stays the same. 7 times 1 is 7. 100 times 1 is 100. So our m's are just going to stay the same. They're not going to change, meaning we have a total of 3 m's, m to the 3rd power. Now for this problem, it's a little bit more expansive, so we need to work on simplifying the top section before we can simplify the division bar. Anytime you have a multi-step exponent problem, start with the largest piece first and work your way down. So on top, we are multiplying. So when we multiply, we add the exponents. So we're going to add the 2 and the 5 to get 7. So once you've simplified something, we rewrite the entire problem. So the top part is now 7 to the 7th power, because we've added those. And we're going to keep the 7 to the 3rd on the bottom because we haven't used that piece of it yet. Now we're ready to treat this like a division problem. And when we divide, we know that we subtract the exponents. And so 7 minus 3 is going to give us 4. The base number 7 always stays the same, and our exponent is 4, 7 to the 4th power. For this problem, we have b to the 5th raised to the 3rd power times b to the 4th. Again, we're going to start with the piece that's more complicated, which is going to be the raising to the power. And your clue is that the exponents are side by side. When we are raising to a power, that means that we multiply the exponents. And so we're going to multiply 5 times 3 to get 15. The exponent b would stay the same. Once you simplify a part of your problem, you need to rewrite it. So we have changed that to b to the 15th, and we still have the times b to the 4th. We didn't do anything with that part of the problem yet. Now we're ready to keep going. That is now a multiplication problem, and we know that when we multiply, we're going to add the exponents. And so we're going to add our 15 and our 4 to get 19. B, the base number, always stays the same, and our exponent is to the 19th power. Again, we have a multi-step problem, 15 to the 4th divided by 15 squared times 15 to the 7th. We're going to start with the division problem because that one has the most pieces to it. When we are dividing, we are going to subtract the exponents. So we're going to take our 4 and subtract it with 2 to get 2, 15 to the 2nd power. We're then going to rewrite the problem, 15 to the 2nd power. We keep the 15 to the 7th because we did not use that piece of the problem yet. And then we can solve the multiplication problem. When we're multiplying, we're going to add the exponents. And so we're going to add our 2 plus 7 to get 9. Our base number 15 stays the same, and our new exponent is 9. For this problem, we're going to start with the raising to a power, which is where the exponents are side by side. When we are raising to a power, it means that we are going to multiply the exponents. So we're going to multiply the 2 times 1 to get 2. Our new problem is w to the 2nd power. We keep the w to the 0 power because we did not use that part of the problem yet. Once we've simplified one part, we can move on to the next step, which is realizing that this is a multiplication problem. And when we multiply, we are going to add the exponents. And so we would add the 2 and the 0 to get 2. The base number w stays the same, and our final exponent is 2. For this problem, it's just a basic one-step problem, 5 squared times 5 squared. We are multiplying, and so when we multiply, we know that we're going to add the exponents. And so we're going to add our exponents, 2 plus 2 to get 4, which means our base number 5 stays the same, and our new exponent is a 4. Now let's review as to why that works, why we can use that shortcut. If we break down 5 to the 2nd power, that means we have 2 5s here, and we also have 2 5s here, which makes for a total of 1, 2, 3, 4 5s, 5 to the 4th power. For this problem, we have 9 to the 5th divided by 9 to the 2nd. Because it is a division problem, and when we divide, we know that we're going to subtract the exponents. And so we're going to take our exponent 5 minus 2, which is going to give us 3, 9 to the 3rd power. But again, let's talk about why that's possible. 9 to the 5th can be broken down with 5 9s on the numerator, that's the top, and then 2 9s on the bottom. We pair up and cancel them one on top of the other, and what we're left with, 3 9s, is our final answer. Okay, we have another multi-step problem here. We're going to start with our raising to a power because that has the most pieces to it. When we are raising to a power, it means we multiply the exponents. And so when we multiply, we're going to use the 3 and the 2, which would give us 6, 2 to the 6th power. Now, we're not finished yet, so we're going to rewrite our problem, 2 to the 6th on the top, and we keep the 2 to the 5th on the bottom because we didn't use that piece. We can now treat this as a division problem, and we know that when we divide, we're going to subtract the exponents. So we're going to subtract 6 minus 5, which is going to give us 1. And so we can say our answer is 2 to the 1st power, or you can simply say that the answer is just 2. You do not have to put an exponent of 1 because we know that the answer is going to be the same, 2 to the 1st power or just 2. For this problem, we have 8 to the 2nd power raised to the 1st power times 8 to the 0 power. Again, we're going to start with the more complicated piece, which is the raising to a power. We know that when we are raising to a power, we are going to multiply the exponents. And so we're going to multiply our 2 and our 1 to get 2, 8 to the second power. We're going to rewrite our problem, 8 to the second power, and we keep the 8 to the 0 power because we did not use that piece yet. We can now treat this as a multiplication problem, and when we multiply, we know that we're going to add the exponents. So we add our 2 and 0, which gives us 2, 8 to the second power. For this problem, we have 1 to the 4th power raised to the second times 1 to the 3rd power raised to the 4th. So we have 2 raising to a powers, so we can start with either one. It does not matter which problem we start with. I'm going to start with the first one. When we are raising to a power, we know that we are going to multiply the exponents. And so I'm going to multiply the 4 and the 2 to get 8. And so I'm going to rewrite my problem. 1 to the 8th power times 1 to the 3rd raised to the 4th, because I didn't use that piece of it yet. Now we can go ahead and do the other part of the raising to a power. Again, just like we did before, raising to a power means that we're going to multiply the exponents. And so we would multiply the 3 and the 4 to get 12. So again, rewrite your problem. Keep the 1 to the 8th, we didn't use that, and we now have 1 to the 12th. Now we have a standard multiplication problem. And when we multiply, we know that we're going to add the exponents. And when we add them, 8 plus 12 is going to give us 20. Our final answer is 1 to the 20th power. For this problem, we have 6 to the 9th divided by 6 to the 3rd raised to the 2nd. We're going to start with the raising to the power because that has more pieces to it. When we are raising to a power, we are going to multiply the exponents. And so our exponents are going to be 3 and 2, which multiply together to give us 6. So we're going to rewrite our problem. 6 to the 9th is going to stay on top. We didn't use that piece. And on the bottom, we have our 6 and our new exponent, 6. Now we have a division problem. And when we are dividing, we subtract the exponents. When we subtract, 9 minus 6 is going to give us 3 for a final answer of 6 to the 3rd power. For this problem, we want to decide if this statement is true or false. So the first thing we're going to look at is that we have exponents that are side by side, which means we are raising to a power. When we're raising to a power, we're going to multiply the exponents. And so I can multiply the 4 and the 3 to get 12. And so I have x to the 12th. On the other side of the problem, we're still raising to a power. So just like before, when raising, we multiply the exponents. We would multiply the 3 and the 4 again to get 12. And so our statement ends up being the same answer. X to the 12th on the left-hand side, x to the 12th on the right-hand side. So this is a true statement. For this problem, again, we're going to solve each side and decide if it's true or false. So starting with the left-hand side is a multiplication problem. And we know that when we multiply, we are going to add the exponents. And so we can add our exponents 4 and 7 to get 11. So we have 13 to the 11th power on the left-hand side. On the right-hand side, we have our exponents that are side by side, which tells us that we are raising to a power, meaning we are going to multiply the exponents. When we multiply 4 times 7, we would get 28. 13 to the 28th power. Our two sides do not match, the 13 to the 11th and the 13 to the 28th. So this is going to be a false statement. Again, with this problem, we're going to decide if the left side equals the right side and whether that is true or false. We're going to start with the left-hand side. The left-hand side is fairly involved. Y to the fifth times y to the 0 divided by y to the third. We're going to start with the top half because it's the most involved. The top half is a multiplication problem. Multiplying means we are going to add the exponents. And so we would add the 5 and the 0 to get 5. To rewrite the problem, we still have the y to the fifth on top like we just solved, and we have the y to the third on the bottom. Now we've changed that into a division problem, and when we divide, we're going to subtract the exponents. We would subtract the 5 minus 3, which would give us 2, for a final answer of y to the second power on the left-hand side. Now, moving to the right-hand side. The right-hand side, the exponents are side by side, meaning we are going to be raising them, raising to a power. When we raise to a power, we are going to multiply the exponents. And so we would multiply the 2 and the 1, which would give us 2, y to the second power. Both sides match once we finalize each side, so this would be a true statement. Okay, this is going to be our last problem, and it is fairly involved, so we're going to take it nice and slow. We're going to start with the left-hand side, 9 to the 0 power times 9 to the fifth divided by 9 to the second. We're going to start with the top because it's most involved, which is a multiplication problem. When we multiply, we're going to add the exponents. So we're going to add the 0 and the 5 to get 5. We keep the 9 to the second on the bottom. We haven't used that yet. We've now changed this into a division problem, and we know that when we divide, we're going to subtract the exponents. So we're going to subtract the 5 minus 2 to get 3. 9 to the third power is our final answer on the left-hand side. Now, moving over to the right-hand side, we start with the top because it's most involved. We notice our exponents are side by side, meaning we are raising to a power. Raising means we're going to multiply the exponents. So we multiply the 3 and the 2 to get 6. Now let's rewrite the problem. 9 to the 6th, and we still have 9 to the third on the bottom because we didn't use that piece yet. Now we can go ahead and solve that division problem. When we're dividing, we subtract the exponents. And so we would subtract the 6 minus 3, which would give us 3, 9 to the third power, for our final answer on the right-hand side. You can then see that they match, so that is also a true statement.